Hello friends, today we will talk a bit about the CAN bus. The CAN is a technique which is quite old. It is just the tens of years in use, not only in automotive, but also in the industry and also by the scientists. This is the universal method of transmitting the information, including not only protocols and methodology, but also the system of connection, which consists only of two wires. So this is just very good for automotive because it consumes less copper, less energy to produce, and so on. Let's try to understand how does it work for us, for tuners. So what can we have from CAN and what can we do with CAN? First, the simplest information is CAN consists of the following parts: the PID identification, which can be 11 or 29-bit. 11, which is the most popular, will look in hex, for example, as 7FF. This is the highest one. Then we have the data, and the data can consist of up to 8 bytes. So then bytes are like 1A, B, F, D, E, A, D, B, E, F, F. 1, 2, 3, 4, 5, 6, so two more, 0, 0, and for example, AA. The last one can be a checksum. The first one can be the count of the data, but this is up to the developer. So the most important information, up to 8 bytes, and the address is this. The PID is the address. Then the system in the car consists of the following elements. It consists of the dispatcher, which is for sending the CAN informations. Sometimes it is named mailbox technology. So it is like ECU consists inside the part, and this part, I zoom it here, okay, so I zoom it now. This part, it is just a CAN module, and it has two parts: CAN send and CAN receive. Every time when ECU would like to send something, prepares the information, so just this structure, and then after it is ready, checksum for example, it is just loaded into CAN dispatcher, CAN sender, to the mailbox, and then it is sent by the mailbox at any convenient moment. For example, the mailbox can have a list of waiting CAN operations, and the ECU sends another one here. So this one waits until all the data is sent. Receiving works the same way. The information comes to the CAN receiver, which of course reacts real time when the data is at the CAN. So this stream of bytes, or bits exactly, comes to the receiver. Receiver has it in a buffer. When everything is okay with the data, then this data, it is just loaded into the list. Yeah, so the new data which is coming from outside, it is just loaded and waits until it is processed. Here is the processor, here is the processor processing. So for that, we need the understanding that the data which is prepared by the ECU and sending and receiving, they are two separate processes. So now we understand that the ECU has something to analyze the data which is received. So let's see how it looks like. We have following structures. Just a second. We have following structure. CAN lookup table. Here we have the index, consecutive numbers. Here we have the address in the memory in a flash, where the information about the PID, so this identifier, is located. This is below this table, you will see this soon. Then we have the mask. So seeing this mask, we can understand this one is the 11 bits. This one is 29. So we can learn more about the information which is received. We have also the information about the functions which are processing the the incoming frame. Let's see, for example, one 11-byte frame. This will be position A. So if I go to the position A, I move the cursor to the position A, to this address, and I press G. So then, as you see, we go to the address, which has the information about the PID. So this will be exactly 7A. I change here. This will be exactly 7E8. After receiving the frame 7E8, it will be identified at this list. And then the proper function which analyzes the data, which can be anything. This data can be really anything and delivered by any ECU or any sensor which sends, computes, can to the ECU, to the main ECU, literally anything. So then we have a function which analyzes the data. Sometimes some bytes are together, for example, because they are 16-bit data. Sometimes even bigger. Sometimes they are shifted, not exactly byte after byte, but sometimes 3 bits, then 7 bits, something like that. It is popular in Tesla cars, for example. So this will be also useful if we talk about tuning Tesla. So this is how the structure of the CAN is built. So conclusion, data is sent always via the mailbox and received via the mailbox. The data is kept in RAM. This list exists in RAM. We can just find this in RAM. We can analyze, we can add our own functions into the CAN bus. We can analyze new PIDs, which are not existing at the moment of the starting the factory program. So sky is the limit, but of course we must understand how it works. So, and the data is up to 8 bytes, can be shorter. And at the beginning, we have the information about the address. So this how basically CAN works, a communication protocol, including the hardware. And now, if we would like to go further, we should just go into Ghidra and continue.
What is mask?
Mask, it is just a method of filtering of information. If we have the mask of, let it be 7FF, it means that only information which is up to that value can be processed. Imagine that the information is sent by the minimal 2 bytes, as here is 1 byte, yeah, here is another byte. And here we can have something like 87FF. So this will be improper value of the PID, but PID filtered by mask, here is 0, of course. So PID filtered by mask will give you the answer of 7FF. This 8 will be removed. So this is method of masking of the information. Filtering, if the information which can come is bigger than the information you would like to process. The most important thing for us, maybe not only for CAN, but for any processing, it is just when we have something like need to analyze 1 bit from 8 bits. We have, for example, the buttons at the steering wheel, and the information is like 11010100. So these are 4 bits, 4 bits. And now we are interested only in checking this, because we understand that this one is the important one for us. For example, you press the resume button, so then it changes from 0 to 1. To avoid checking this or analyzing this, we can just block them by masking. So we just prepare mask, and the mask will be 0, 0, 0. Permit this one to go through, 0, 0, 0, 0. So after masking, we will always have here answer of 1, 0, 0, 0, 0 or 0, 0, 0, 0, 0. So now we can simply see only this one button. This is masking.
In all cards, this mask same.
Method of masking is the same for all cars, and it is one of the most popular binary operations. So we have this in CAN. We have this in processing of the information from sensors, not only from CAN. also the processing of the several bit-wise information, so several information which is coded by bits, but sent by bytes, or 16-bit or 32-bit, always uses masking.
This short mask. And tell me about long mask.
The long mask is if the address is not sent up to this value, but the address is 29 bits, not 11. In that case, we have not 7FF maximally. We have like 1FF, FF, FF. So for that, we need to have a longer mask. Here I don't see them, but okay, I can just roll. Wait a second. I will just show you here. For example, these are the short masks, and here you have a long one. So then if you just send the, here should be 1F more. If you just send the 32-bit PID, in that case it can come also here with a value bigger than 1. So we should mask it to avoid the information being, for example, FFFFFF. So if there are all Fs and we mask them with this mask, we will receive 1F. So this is what we need to have. So there are two structures, the shorter version of the PID and longer. So they are short mask and long mask. Short version was a primary version, 16-bit long, but only up to 7FF hex. And the long mask is 32-bit because the address can be 32-bit. It is just more modern, let's say. They are mixed in one program.